right?
Yes, sir. In here, the first question is let ABCD be a trapezium
Mm-hmm.
in which AB is parallel to CD
Mm-hmm. Okay, AB
and
parallel.
AB is equal to 3CD.
Yeah, this way it's actually faster also. AB equal to 3CD.
Let E be the midpoint of the diagonal BD.
Mm-hmm.
If area of ABCD is n times area of CDE,
Mm-hmm.
what is the value of n?
Right. Okay. So let us do that. So we have AB, big AB, relatively small CD. So you see the trapezium is not completely given to us, right? There are a lot of unknown things, okay, in the trapezium. We don't know the length of the other sides. We don't know the length of any side. Yeah. So this is midpoint would be maybe here. CDE. CDE by ABCD. So we want that ratio. So how do we do it? So let's try it now. See. Okay, so any ideas? So today I'll go a little fast maybe, okay, because just in the exam feeling a little bit. CDE is half of BCD. Any other observations?
Sir, shouldn't it be 1/4?
No. It is not similarity. It is just the base and the common base thing. Are you getting it?
Yes.
Right? It's a common base thing. So the CDE I'm comparing with BCD. Now what's my task? Now I want to compare BCD with the whole trapezium. Can you compare? So is this question for you? Can you compare BCD with ABD? So we are growing from CDE to BCD to ABCD. So I'm going to ABD. That's also a
Is
triangle.
it 1/3?
Yes, that's right. Now we are only left with calculations. I will just reverse this. Five, no, four, right? Okay, because that was 3 times BCD, and so whole thing is 4 times BCD. Yeah, is that okay? Then you can tell me the final answer.
It should be 8, right?
Yes, right, correct. Good. So we are done. So you see the way we are doing, we are not calculating everything. Yes, based on this is bigger, that is bigger. So whether it should be half or 2, 4 or 1/4, those things you do it quickly, just based on many things, not just calculations. Okay, let's move to the next question. Oh, I closed my Chrome. No, because you were telling me the questions. Yeah. Yes. So say the next question.
A number n in base 10
Hmm.
is 503 in base b and 305 in base b plus 2. What is the product of the digits of n?
But do you understand the question? Base thing?
Sir, I haven't learned much about bases.
Right. Okay. So you see, when we say that we have a number n in base 10, right? So n is a quantity, how big or small it is. Okay. When we write it in base 10, what do we mean? We mean that you divide n by 10 and you look at the remainder, right? That forms the first digit, units place. And then you continue the process, right? You take the uh, whatever the dividend and you divide that by 10 and you again write in that way. Then when you do this, then we get something like this. It could be anything that we don't know. I mean, okay, we know, but in some sense. So basically, it's n that was the quantity. We decided to write it in terms of powers of 10, right? This we never do because the number is just given to us like that, usually, right? The number is given to us in digits. So we never really have to do this, okay? So these turn
Yes,
out
sir.
to be the, right? And these turn out to be the digits. But so basically the digits of a number in base 10 are those A1, A2, A3. So similarly, when you take the same number and you write it in a different base, let's say in base 5. Let's just take a quick example. It is better. So let us take 537. Now when we say 537, we mean that it is in base 10. Unless anything is said, by default, our understanding is that it is in base 10. It is a number 537, 500 plus 30 plus 7. But then you can write it in terms of, let's say, powers of, let's take 6. Okay. And then how do you write it? You simply just do the division process. So you divide this by 6. So what do you get? You get 1 as a remainder. Sorry. Yeah. Yeah. So I got disconnected. Anyways, yeah. So what was I saying? Saying that if you have this number, let's say 537, you write it in base 6. So can you try to write it in base 6? Meaning divide it by 6, see what you get and so on. So let's do it.
Sir, I cannot see your screen.
Okay. Okay. What should I do? So stop share and then share again. Can you see now?
Yes.
Okay. So we want to write this in powers of 6. Okay. I want to write this in powers of 6. So what is it that you get? 6 is the 48. 5 4 plus 3. Then we just take this dividend that we got and we divide it again by 6. Okay. You see, in this way, you will get the powers of 6. And this kind of process is used in polynomials also in many places. And then we again can do the same thing here. So what do we finally get? You have to write it in powers of 6 by any way, and this is a convenient way to do it. Okay, so you see that number, that quantity 537 that comes in the number line when you take 537 steps, that quantity has the representation 537 in base 10. Okay, but in base 6, what will be its representation? 2253. So these are the digits in base 6. Okay, so these are the digits of a number in base 6. What is that number? That's a philosophical question. What is that number? But when we say what is that number, means what is it in base 10? So we say the number is this. The quantity is this, and its digits are 2253. So is the concept of base slightly, there now? Because I've just for 5 minutes said something first.
Yes, sir.
Yeah, slightly what it means for a number to be something, to have digits in certain base. Now let us let's keep this here. And so again, I will not write the whole question. But I've forgotten the question again very quickly, very volatile memory. Uh, but it was in base B. Can you just say the main
Yeah, a
points?
number n in base 10 is 503 in base B.
Okay, 503 in base B. What does it mean? So it means that in base B, the digits are 503. So what is the number? Number is 3 plus 0 times B plus 5 times B square. Okay, so there was a number
Yes.
which we wrote in base B, and then we got this expression, and so 503 became its digits. And it was something in base B plus 2. What is
It's
that?
305 in base B plus 2.
So you see the same number n is 305 in base B plus 2, which means that when we wrote it with respect to B plus 2, again, this thing is middle term is simple. This is all the question is saying. Now we are asking for product of digits in base 10, right? That's the question. So what do you have? You have 5b square plus 3 equal to, now quickly find the b. I think you can do it now.
Seven.
Yes, I was being smart and that's why I made a mistake. Oh, you found the b?
Yes.
B is 7. Oh, good. Yeah, that was, I forgot that. Oh, so that's good. Now there is nothing to do, right? Problem is done. Because now you know the number.
Yes.
That's it. Simple. So no, bases are very important thing. They have very interesting properties. But for this exam, you need to just understand what it means. Okay, and go back and again maybe just think about it for some time. Okay, yeah, I've given a number. Now when I'm writing it in base 10, or base 10 is given, in some other base, any base 12, then what does it mean? Okay, a number in base 12, a number will not change, right? Its digits, the way it's represented, will change when you write it in base 12. And what the digits will be? They will be those coefficients in the expansion in powers of that, whatever, 12 or b. And the same number is written in 2 different or 3 different bases. And that much. So, okay, fine. So now let's move to the next question.
The next question is summation of if k equals to 1 to n.
Mhm.
2k plus 1 by k square plus k whole square is equal to 0.9999.
0.999.
Yeah, 4 nines.
Oh, okay.
Then determine the value of n.
Uh, so we had done a little bit of partial fractions kind of thing. And so the idea is to try to apply something like that. Or maybe just simplify that expression, they split that expression or something. Hi, Aparna.
Sir, actually, I had written it also, but I thought that the class was at 9. And then I realized that it was actually at 8, so I just jumped.
Oh,
Sorry.
no, you should just not miss. Yeah, okay, no problem. Let's start. So this is the question. So there is this, we did 2 or 3 questions, and this 2k plus 1. So this is the summation. The summation, do both of you understand the summation notation? What this means? Put k equal to 1.
Sir, it's like I think you put k as 1, 2, 3, n, and you just add those values.
Yes, that's all that summation notation means. So you can do that in your notebook if you need to. That yeah, this is like this. This is equal to this. We want to find the n. Okay, so today we are doing things a little faster. Find the n. Class timings, note it down. When I say it, you should note it down because there are other things you may forget. Let me check the mail. Oh, I did not get an email. Anyways, leave it. See, the idea as this kind of question we did once. I don't. The idea is to try to split the term. So you look at a general term. General term is 2k plus 1 by this thing. And try to simplify it. Try to write it as a difference of two things or something like that. Like I'm writing it like this. Square of this actually. Yeah, but I don't know if that will be useful. So you see, you can split it. You can write it like this if it's useful.
So won't it be k square into k plus 1 the whole square?
No, because that's the thing, right? Because this, so there was a k plus 1 here, right? And that got cancelled, right? Similarly here, right? So it was like this, and then things cancelled. So far, I don't know how to do it. This one is. Plus 1. It's k square plus k, and then there is another square. That is.
Sir, if we write the numerator as k plus 1 the whole square minus k square and try to factorize.
That is the correct way. Yes, that is the correct way. That's just better in this situation. Yeah. Now from here, try. I will say later there are means this thing you're able to see by based on what it should be, and that is actually the correct thing. But there are formal ways to get these things, means why it should be this, but that is not exam friendly. Yeah, this is the better, just seeing what is correct, what looks good. From here the problem is easy, so try it. The meeting, if it ends, just join again.
Sir,
Yes.
so from here we'll just have to put the values of k and try to solve it, right? Like from 1 to n, and we can get n's value.
Yes, because now the summation is simple.